Hey guys, my name is Alex, and today I'm going to attempt to show you around my 3D printing setup. This will be important later because I'm running a company that does 3D printing related stuff, and also I've got a mechanical engineering degree, so this is all really interesting to me, and I do think that revolutionizing manufacturing is one of the gateways to building a better society. So, um, I wanted to start by just kind of showing you guys where things are right now, because I will continue to work on them. And the other thing I'd like to do is kind of go part by part in the future and kind of show you the design process and the upgrades that I've been making, to kind of explain to you the rationale behind what I'm trying to achieve with like a more universal CNC type manufacturing environment. That being said, sounds pretty technical, doesn't have to be. I will try to explain this in a way that would make sense to pretty much anybody. And of course, comment section is always a good place to ask if you need clarification. And even if I can't help you, other people probably can. So that being said, let's get on with it. Um, so yeah, Prusa Mini right here. Love this thing. I called it Printy. It's super cute. And this was its original face. It used to have googly eyes on this. Um, but it is updated into a big boy now. But yeah, so this thing, I when I was doing research, I used to work at the labs, um, in my mechanical engineering department, and I would just go there at night and kind of like experiment on 3D printers and like learn how to develop things. Because even my freshman year, I went to college for 6 years, and so that was a lot of time to get practice and have a lot of ideas of the things I wanted to do in the future. Um, so even when I was a freshman, I was thinking like, oh man, I'd love to 3D print like a prosthetic arm or like replaceable joints in machines. Like I want to design new things is basically what I'm getting at. And so eventually 3D printing became the way for me to do that. I gave myself 2 weeks and I was like, I'm going to start a company from start to finish. I'm going to go from having the idea to having a product and make my first sale in 2 weeks. And it worked. And then I did not make a lot of money after that. So I'm trying to figure it out right now. And you guys will probably get taken on the journey with me. That being said, um, so yeah, I was experimenting in a lab, and I was like, oh man, what printer do I buy? And my lab advisor was like, get a Prusa because they're great. And I did my research, and yeah, they are, especially for the price. Um, the one feature this thing has that like not really any other printers have, is automatic bed leveling, which is when the printer itself will go around and it'll test various points on the bed. This is the print bed, and make sure that the bed is flat, or if it's not flat, figure out what shape the bed actually is, right? Because the bed can be like curved a little bit, and this way, when it's printing, it'll make like layer upon layer upon layer that are actually in line with each other. Because some printers, they'll wind up with like a layer shifted, and then your whole print is kind of ruined after that. Or it won't stick, and it'll come off looking like this, which is what happens when a print fails. This is a print that I tried to run remotely while I was at work the other day. Almost terrible idea, I'd say. Anyways, so yeah, you need a lot of rambling, but I like to tell stories, and I think it's cool because it's kind of been a journey to get here, and it's going to continue to be one. Um, and also, this is just something I love to do. So yeah, I my big thing was like, okay, I want to run a factory, right? And a lot of people do run like 3D printing farms, and they'll take they'll basically like loan out their 3D printers print time and filament, um to whoever wants to buy it. So they're like, hey, you can print on my printers. I will make sure that it actually runs properly, and then you'll get it when you're done. Um, I don't really see that as the way to go forward. And I was looking at, what are other manufacturing methods? If I want to like my original product was a toothbrush holder, um, and I was like, okay, man, if I want to make these faster, like the original ones were taking like an hour and a half or more to print, and I was like, this is ridiculous. I could never keep up with demand. Turns out demand's pretty low when you don't have a lot of products on your store. Um, but anyways, so I was looking at like injection molding and seeing like, oh, can I make this out of metal? Can I make this out of plastic? Like, what else should I look at? Um, and it looks like 3D printing is the best option, but I had to do a lot of optimization. So that's where Prusa slicer comes into it, and that's not even what I'm showing on my screen right now. We're gonna act like it is, because this is Prusa slicer. It's pretty cool. It's a beast of software. So yeah, so the parts of this that I have made edits to, let me just walk you through them real quick. That's background story, and you're gonna get a mixture of the two, of tech and backstory, and future projection, whatever. But yeah, so the things that I have made edits to, I've made a ridiculous amount of edits to the settings in Prusa Slicer, because without doing that, these prints would take for freaking ever. And I'm not even kidding you. This, like these cats, I mean, this is a pretty solid print. This is like I've optimized this a lot. It's very bright. You can't really see it. It's got like a little face. It's super cute. But originally this would take like 3 or 4 hours to print. I got it down to 1 hour and 33 minutes, which is what it says on the back of the head of this one. Because I was running tests. This is called a calibration cat. And it's on Thingiverse if you want to go check it out. I didn't make it, but I think it's super adorable. But yeah, so I'm like testing out, what is the fastest I can make something without it getting like completely shreked or destroyed, right? And then we've got some pretty horrible like results of that. I don't know if you can see it, but it's like it's webbed, its head's like coming off. And it sucks because when you use something like a kitten to test these things, you get very emotionally attached to them. It's very sad to see like kittens that have kind of been hurt by the machine. Anyway, so yeah, so my settings allow me to print about 6 times faster than the original settings would, although mine are much more experimental. So like the fastest one of these I printed was under 30 minutes, which I think is very cool. And this is not my first time working with optimization, but I think it's very central to actually like making a functioning company or project. So yeah, I redid those settings. Then my next step was like, okay, I want these prints to be able to remove themselves when they're done and start the next one, because I can't be around to run this company unless I'm paying someone, and I'm not making enough money to even pay the upkeep costs, let alone myself, and definitely not someone else. So yeah, so I was like, I need this printer to take care of itself. It needs to run itself. And so I got this little, it's a Raspberry Pi, it's in there. You can't see it. It's like this big, it's like a credit card sized computer. And it is literally like running a computer. I hooked up a monitor to it, like a screen. And I set it up with like, yeah, just like the basics that it requires. And then from there I started making edits. But then I had to design a case for it, and I like took out the old screen that came with the printer, and I put the two of them in one case. And now it's got a touch screen, because there's like a little screen that I got off Amazon in there. The other things, I'm like starting a company with no money, relatively speaking. Definitely more fortunate than some other people have been, but I'm trying to start it with as little cost as possible, because I kind of want to go straight into this if I can, rather than having like a long career and spend a lot of time kind of working in a direction that's counterintuitive to where I want to go with my life. So yeah, so I kind of set this all up. And then I had to like figure out wire management, and the printer used to be a lot more unstable. So this is version 1. When I designed this thing, this is all it had, and then I don't have it like right in front of me. But essentially there was like this little razor blade that used to be attached to the printer's head, and when it finished, I would like go down and it would run into the print and it would pop off. But it's a very violent popping, and it wouldn't always work. And sometimes it would damage the print bed because it's a blade going into this thing, with a lot of force behind it. And so I don't want to destroy my printer. The reason it's able to print accurately is because I take good care of it most of the time. And so the question then becomes, well, how do you easily get something off? And so then I was like, okay, well, what if I did a slope? Well, first I wanted to like just push against the part. The part's here. When it's done, it pushes, but then the force is so distributed that it doesn't really get much of a grip, and the motor stalls and it just keeps skipping and nothing happens, right? The part doesn't get knocked off. So I tried another one, which is the original head for Printy, and it's got this like little thing with a draft angle in it. So it's like when the print is over, this goes over it, and then it'll move to the side, and the object that was printed gets stuck in here and then gets knocked off, which was cool, except it didn't totally work. And that was a disaster. It's for another day. Um, but yeah, so V1 had those two things and had the blade. This was an updated attachment, the one I just showed you. So now we're on V2 because yeah, we're on V2 because I finally had some new ideas, and I just had V3 ideas, but V2 doesn't totally work. Just saying. Um, anyways, so then I was like, oh, well, what if I experiment with temperature? Because one of the things that makes it easier to remove an object from the print bed is if you change the temperature of it pretty quickly, because the plastic expands and contracts at a different rate than the metal that the print bed's made out of. So inevitably, well, they're like, you have to imagine like two parts. If you're close to the center of the object, they'll stay stuck together. But if you're further away, when it's shrinking, like up close on a microscopic scale, you can imagine like one is moving towards the center and the other one is moving at a much slower rate towards the center. And so eventually they're so far apart that they get ripped apart. Um, and so then you have like very little contact area. It's very easy to knock something off. And so I was like, okay, this is great. However, those tests have also kind of gone awry because I was like, oh man, maybe I can start really hot and then cool down. And that was working. I was printing with PLA on a bed that was 100 degrees, and it's like not super smart, but it was working. I was using Hatchbox PLA back then. Kind of wish I still was, because right now I'm using I think it's Overture, and their PLA like becomes so soft so quickly, and so like literally this is my 100-degree test on Overture PLA, and like I don't know if you can see that the bottom is destroyed. It melted into the bed, even though it's 100 degrees cooler than it was printing at. And I guess PLA just has like a very cold melting point, so there's not much I can do about that. I'm just gonna keep running tests, but I want to make these things quickly. Like this cube takes 6 minutes to print, and usually it would take like an hour. So I need to be able to keep print speeds up like this, because if I'm running this like it's a factory rather than like it's a hobby, if if something breaks down and I'm running like 4 prints a day on this thing, I'm screwed. But if I have something that can print like instead of 4 hours in like even 40 minutes, right? That's 6 times as fast. Then now I can get things at a reasonable pace because I can print 24 objects in a day, which is great. So anyway, so temperature separation, that was a huge thing. And there's like, I've seen a few people try this online, but it like didn't really look like it worked, and it was a little bit concerning that other people haven't tried it. But the people that I did see online have like added like paper to the end of their print bed, and so when they move it back and forth, the object will get knocked off, and then it'll slide off into like a bin or something. You can't. I guess you can't see it, but there's a bin here. And I was like, one of the tests that I've done a lot, and I'm quite proud of, is figuring out how to make sheets really fast and really like good quality. And so yeah, I 3D printed an extension to my bed, and then I made it rigid because I don't want the object to like fall off the side of it. So there's a bar in the front and the back so that it can't bend from side to side. It can only bend like top to bottom. And then I had to add a weight to it because it's not pliable enough. It won't bend enough for it to like fall into the box. It's kind of like missing the box. So yeah, I mean that's an issue because now it's adding like more weight to the printer. It's moving the center of mass. So I mean, it will become an issue. Like there's points in the while it's printing where it just keeps like knocking against the bed, and I can't have that happening. It's a temporary solution, so it's V2. But what was really cool was when I realized that there was like too much pressure being put on this, I was like, oh, let me slow down the speed that it's knocking things off at. And when I did that, this thing is magnetic, so it literally just pulled the print bed right off. The motor kept moving, the print stayed where it was, and then the printer acted like everything was fine, and the object still stuck to the plate. So problem's not solved there. However, I added these little clips because they're screws underneath the bed, and now when it goes to push on this bed can't like the magnetic part can't slide off because it's locked into the screws. It's like a little clamp. So it's like, okay, now I've got a way to prevent this from moving. I've got a way for it to fall off into the box. I've got this thing where I can automate it, and there's an extension, a plugin on an Octo print, which is what I'm running on the Raspberry Pi. I realize there's a lot of moving parts here, but I've been working on this for like a year now, and so yeah, so the when I'm automating it, there's that plugin continuous print, which like allows you to write G code or code for the 3D printer at the end and beginning of a print, and then you can queue all of them, so you're running them back to back. And I was like, okay, this might take it in, because I had written code previously that my business is on Etsy, and I had written code that could look in my Etsy emails and take what things people had bought and put them in a spreadsheet. And then I was like, oh, I want this to go from the spreadsheet into the printer, but I didn't want to have to code that. I don't know how to code APIs, which is like what you would use to speak from like one application to another. And I don't know that. So I was like, okay, what's an easier option? Turns out this existed. I'm very grateful that a community exists around stuff like this, because it makes everyone's life easier. But yeah, so I connected that up, and then so now I can queue a bunch of things, leave it running, and the next step up was like a few days ago. I figured out there's this thing called Octo Everywhere, which I've searched for this kind of stuff before, and I don't know how I never found it, but it lets you host your like instance, your Raspberry Pi, whatever, from here to anywhere on the internet, and it's free, which is super cool. But what was happening essentially is like I can only I can access this on my phone and on my computer and control it, but I could only do that while I'm on my home Wi-Fi, and that's not going to cut it. If I'm somewhere else, if I'm at work, if I'm out on the town, as if that happens, I want to be able to run this thing, because it needs to work even while I'm sleeping. And yeah, so then it was like, okay, if I host this, well, now that's another piece of the puzzle solved. So I think that that's a really cool thing. And then last thing is my spool holder. I just thought this was like kind of cool to make, because I really want printers that are like every single piece of it is connected. And so I originally had like I don't know why I keep moving all my things. Okay, whatever. It's the spool holder is like shaped like this, and it like clicks onto the side here of the bar, and then you can have your spool rotate around it. And it was pretty good, but it would slide up and down sometimes, and this is just better because the weight is actually vertical. And then this was an interesting challenge. I came up with this like 2 nights ago. But the thing is, if this is spinning, then the filament is loose and it can just fall off the spool. So I measured the diameter of this filament, and I was like, okay, I know the filament can at least handle this kind of curve without snapping. So I built it around that. The filament fits perfectly over the motor that's already there. All of these, what do you call it? All of these ball bearings are ones that already came with the original spool holder that came with the printer, which is this. And then, yeah, and then what else? Oh yeah, and so then I was like, okay, well, I'm just gonna make a channel that has that same curvature as the spool, and just use it to change direction from going horizontally to going vertically. And now it connects into here, and so far I've had no problems. So it's just kind of like a cool little thing. Like I never expected to make tracks like this, but it's like now that I have, there's so many things that you can do with it, and it kind of keeps being this story over and over and over again. It's like I love testing on this thing, and you screw something up really badly, and you're like, oh wait, there's a use for that. Like I designed like a fake curtain rod holder because my curtain rod ends didn't fit on the wall in the place I was living in, and then I was like, oh man, what if I 3D print like the ties for the curtains too and make them look all fancy? It was a terrible idea. I got cut on it, and like it didn't bend right, and then it started cracking, and that was my fault. But it had a lot of potential to be cool. I just didn't know how to use it. So here we are, many iterations later, of learning this kind of stuff. And then yeah, the last thing is like there's a keyboard and mouse that hooks up to this. You can't really see it right here, but I keep this here. It's mostly for logging in, and everything else is touchscreen. But yeah, I mean, there's so many moving parts here. I really just wanted to give you an overview, because the stuff you're going to be seeing after this is me really taking that last step from like hobbyist printer into like professional printer, because at this point everything I do will actually be for printing products for this company. Um, I realize I haven't said what it's called. The company I run is called Vasari Design, um, and there's a whole story for why it's named that. But you can find me on Etsy if you care that much. Anyways, um, yeah, no, I love this stuff so much. My mechanical engineering degree was a nightmare. It's also another story, but the value of the knowledge from that is not something I can put into words, because it's enabled me to like make the ideas I have in my head come to life. Um, and you'll see plenty more of this kind of stuff coming forward, because I literally wanted to design stuff since I was a kid and just like could only do it in Legos, and now I can do it with like real life like big boy stuff. Um, so yeah, and plenty more googly eyes are probably coming your way too. So anyways, I like storytelling, but I also like rambling, and I get that that's where this is headed. So it's been a pleasure talking to you. Please comment.